This is Module 1, Lesson 6 on negative exponents. Now, they've got some rules set up here for you. X to the negative n is the same as 1 over x to the n. Okay, x to the negative 1 is the same as 1 over x. X to the negative b is the same as 1 over x to the b. Let's see what they're actually talking about. If I were to have 3 raised to the negative 2 power, what this means is that would be 1 over 3 to the positive 2 power. See how the sign on your exponent changes whenever you're doing this, positive and negative whenever you're going to the fraction. And 1 over 3 squared is the same as 1 over 3 times 1 over 3, which is 1/9. What if we're saying x to the negative 1 power? What if I had 4 to the negative 1 power? That's going to be 1 over 4, and it's actually 1 over 4 to the first power, but we know anything raised to the first power is simply itself, so that's 1 over 4. And what if we've got this situation, x to the negative b? Okay, well, we did one just like that a minute ago. What if I've got 2 to the negative 4th power? That would be 1 over 2 to the 4th power. That's 1 over, you could do it this way if you wanted to, 2 times 2 times 2 times 2. That's 4 times. 2 times 2 is 4, times 2 is 8, times 2 is 16. That would be 1 over 16. All of these are equal to each other. Now, the first question it has down to here is verify the general statement x to the negative b equals 1 over x to the b for x is 3 and b is negative 5. Verify means prove or check. So let's simply plug things in. If x is 3, that means 3 to the negative, and b is negative 5, opposite of negative 5, equals 1 over, our x is 3, our b is negative 5, okay? In this case, opposite of a negative is a positive. That is 3 to the 5th would be equal to 1 over 3 to the negative 5th. And when I've got a negative, I'm going to flip it back over. This negative, it's always going to put it on either, if it's in the denominator, it'll be in the numerator. If it's in the numerator, it will be in the denominator. That would be 3 to the 5th. Okay? What's the value of 3 times 10 to the negative 2nd? Well, let's look at this. We keep our 3, and 10 raised to the negative 2nd. Okay, we've already talked about this. If I've got a to the negative 2nd, that's the same as 1 over a to the positive 2nd. So if this is 10 to the negative 2nd, that would be 1 over 10 to the positive 2nd. That is 3 times 1 over, and 10 to the 2nd is 10 times 10, which is 100. That would give you 3 100s. This is write an equivalent expression in exponential notation to the one given and simplify as much as possible. 5 to the negative 3rd power. When we are raised to a negative power, that's the same as 1 over 5 to the positive 3rd power, right? That's 1 over 5 times 5 times 5. 5 times 5 is 25 times 5 is 125. All of these are equal. Exercise 6, that's 1 over 8 to the 9th power. Let's see, that's the same thing as 8 to the negative 9th power. Whenever it's on the bottom, change the sign on your exponent, flip it to the numerator. 3 times 2 to the negative 4th, you keep your 3 because there's no exponents there. Multiply that times 2 to the negative fourth. That would be 1 over 2 to the fourth power. That gives me 3 over 2 to the fourth power. That gives me 3 over 2 times 2 times 2 times 2. That's 3 over 2 times 2 is 4 times 2 is 8 times 2 is 16, 3/16. And x to the negative third power, that's 1 over x to the third power. What if we've got 1 over x to the ninth power? The opposite of that is x to the negative ninth. X, y to the negative fourth. You leave x alone, and the y is 1 over y to the fourth. So what you've actually got is x times 1 is x. That's x over y to the fourth power. Here it shows it to you. A to the negative n is 1 over a to the n. Okay? So if you're given 1 over a to the n, it's the same as a to the negative nth power. They said for any any non-zero number a raised to a negative exponent, place the power in the denominator to rewrite the power with a positive exponent. Now, let's look at this. If I were to do this, okay, if I were to try this, we know if I'm dividing and I have the same base, then I subtract the exponents, 2 minus 5. That would give me b to the negative third. Let's look at this another way. B squared is b times b. B to the fifth is b multiplied by itself 5 times. Okay. I can cancel these b's, these two. I can cancel these two. That gives me 1 over b times b times b. Oops. Gives me 1 over b times b times b. That would give me 1 over b cubed, which is b to the negative third power. Okay? Let's see. On this, 2 to the negative third power, that's 1 over 2 to the third power, which is 1 over 2 times 2 times 2. 2 times 2 is 2, is 4, times 2 is 8. That's 1 over 8. And negative 3 to the negative third power. We take negative 3 to the negative power means that it is 1 over that to the positive third power. That would be 1 over negative 3 times negative 3 times negative 3. That is 1 over negative 3 times negative 3 is 9. It would be times negative 3, which gives me negative 27. 1 over negative 27 are the same thing as negative 127. And let's look at the odd ones here. We know x to the negative a power would be the same thing as 1 over x to the a power. If I have x to the negative fifth power, that's 1 over x to the fifth power. Let's look at this one. Look, negative 7 is a coefficient. You don't mess with it. This is a to the negative fourth power, so that is 1 over a to the fourth power. See, I'm multiplying here. Times b to the third power. Let's make that fourth a little bigger. Negative 7 times b to the third power is negative 7 b to the third power. And what do we have in the denominator? A to the fourth power. So our answer is negative 7 b to the third power divided by a to the fourth power. Simplify each expression. Make sure final answers contain all positive exponents. So we're trying to get this to all positive exponents here. In other words, see how we did this one? And we made sure that negative exponent was here on the bottom. Let's do the same here. 4, there's nothing on it. We leave it alone. C to the 8, it stays where it is. This is d to the negative third, which is We're going to substitute that with 1 over d to the third power times 5, that's c to the negative fifth power. That would be 1 over c to the fifth power times d to the negative 1 power is 1 over d. Now let's see what all's on the top and what all's on the bottom. We have 4c to the 8th power, okay, times 5 times 5, right? And what's on the bottom? We have d to the third, c to the fifth, and then d here. Okay, so this be d to the first power. Let's multiply our coefficients here. 5 times 4 is 20, so that's 20c to the 8th power. Let's combine our d's here. If you're multiplying, you add your exponents. So I've got c to the 5th power, d to the 4th power. Okay? Let's look at number 7 here. Combine our like terms. Let's go ahead and combine our like terms. We've got a to the 5th power and a to the negative 5th power and a to the 7th power. So that would be 1 over a to the 5th power times a to the 7th power. Okay, that's my a's. Let's do our b's. We've got b to the 8th power times 1 over b to the 3rd power. And then on the c's, we've got 1 over c to the 12th power times c to the 7th power, okay? This gives me a to the 7th power over a to the 5th power times b to the 8th power over b to the 3rd power times c to the 7th power over c to the 12th power. When we are dividing, we subtract exponents. 7 minus 5 is 2. That's a to the 2nd power. 8 minus 3 is 5. B to the 5th power. Okay? 7 minus 12 is negative 5. Okay, so I've got a negative 1 here. That would give me a squared b to the 5th over c to the 5th. That's 1 over c to the 5th. That's what you'd wind up with. Let's look at 9. Now we're distributing our power. Okay, this is a coefficient, so we distribute that to there. That's 5 to the negative 3rd. Y to the 2 times negative 3 is negative 6. That would be 1 over 5 to the 3rd times 1 over y to the 6th. That gives me 1 over 5 to the 3rd, y to the 6th. 5 to the 3rd is 5 times 5 is 25 times 5 is 125. That's 1 over 125 y to the 6th. Let's look at number 11. We're going to distribute this negative because this is raising a power to a power, and that is a coefficient. That would give me 6 to the negative 2. X to the 5 times negative 2 is negative 10. Y to the negative 4 times negative 2 is positive 8. That's 1 over 6 squared times 1 over x to the 10th times y to the 8th. If I multiply across, 1 times y to the 8th, y to the 8th is on the top. That gives me 6 squared x to the 10th. Let's square our 6, that's 36. Y to the 8th over 36 x to the 10th. Let's look at these. I'm going to divide these up into the c's and the d's. I've got c to the negative 2 divided by c to the 7th. Negative 2 minus 7. Negative 2 minus 7. Whenever you've got a subtraction, you can rewrite that as the addition of the opposite. That gives me negative 9. This is c to the negative 9th times d to the, I've got -1 minus -2. -1 minus -2. When you're subtracting, add opposite. Add, and the opposite of -2 is a +2. Goodness, I didn't write that very well. That's -1 plus 2, which gives us 1, okay? D to the first. That would give me 1 over c to the 9th times d to the first, or just d. That gives me d over c to the 9th. And then 15. Let's split these up. Here are your coefficients. Then you got your m's and you got your n's. Okay? That's -10 divided by 2 times m to the second over m to the third times n over n to the -5th. -10 divided by 2 is -5. When we are dividing, we subtract our exponents, so that gives me m to the -1. 2 minus 3, 2 minus 3. When you're subtracting, it's the same as adding the opposite. That's -1. Okay? So that's m to the -1. You know there's nothing on the end, which means there's an understood 1 for an exponent. 1 minus -5, when you subtract, is the same as adding the opposite. That would give you 6. So that's n to the 6th. Now, that's -5 times 1 over m times n to the 6th, which gives you -5 n to the 6th over m. Okay, the rest of the problems are for you to work for homework.